Okay, in this video, we're going to be talking about the a line segment, the length of a line segment, the segment addition postulate. So just a few things here. Let's start out talking about what we mean. How do we measure line segments? And again, we talked a little bit about lines in the previous video. Now, a line extends forever in two directions. You see here this whole thing with the arrows on both ends. These are lines, as you can see down through here. But in this video, we're going to be talking about line segments. Now, line segments are measurable. Measuring segments, the distance between 2 points A and B can be written as the length of AB. Now, notice how I denote this with our symbols here. If you just have two letters, AB, it has no symbol, there's no symbol above it, you just have the two letters. That is the length from A to B. That's how far is it from point A to point B is what we mean. It's the length of line segment AB. And I should have put that over the top because the length of line segment AB, or just AB with nothing over it. Now, how can we find that? Now, if you're dealing with a number line here, you can simply count. AB, again, notice there's no symbol above it, is how far is it from here to here? How far is it from -1 to 3? You can do the math there by subtracting, or you can just count 1, 2, 3, 4. So AB here is 4. Okay, next up, let's talk about what we mean by congruent. If two line segments, AB is equal to CD. Now, let me again point out, I didn't put the symbol above it. If I say AB, let's go over here. What I mean by AB is how far is it from A over to B? What do I mean by CD? How far is it from C to D? I'm talking about the length of those segments. If AB is equal to CD, then the segments are congruent. Now, we got to be careful here. This is not the symbol for congruent. Shapes are congruent. Lengths or distances are equal. Okay, so if we're talking about the two lengths, now the length of this line segment and the length of this line segment, the distance from here to here and the distance from here to here, those values are equal. Since they are equal, that means the segments, the actual shapes, the actual line segments are congruent. This is written as AB, line segment. The segment is congruent to the other segment. Why are they congruent? Because their distances or their lengths are the same. So we got to be careful. There's a difference between the word congruent and equal. Distances are equal. Shapes are congruent. Now, next up, we have what's called the segment addition postulate. We're going to be using this segment addition postulate all throughout geometry. The segment addition postulate says this: if A, B, and C are collinear, and a reminder, the word collinear means that they're on the same line. And you see that over here, A, B, and C are collinear. Are there collinear points, and B is between A and C. Then we know that the length from A to B plus the length from B to C. Now let's finish this statement. What if the length from A to B is 2 and the distance from B to C is 8? Then what can we conclude? If this is a distance of 2, this is a distance of 8 more, then how far is it from A to C? How would we find that? We would take this, we would add it to this, and that tells us the distance from A to C would be 10. So what does that mean? Let's put it all in this now. If AB plus BC, if you were to add those two, that would give you the length AC. This distance plus this distance is equal to the whole distance. That is called the segment addition postulate. We're adding segments. We're adding the two small segments to give us the length of the larger segment. Now let's actually use the segment addition postulate in some examples. Use the diagram below for questions 1 and 2. If PQ is 9, QR, the distance from Q to R, is 28, then what is the distance from P to R? Well, if this is 9, and then this is 28 more, then the whole thing will be 9 plus 28, or 37. Number 2 says if QR is 17, and PR, that is the whole distance, is 21. Now, how can we find that? If the whole distance is 21 and we take away the 17, which is this distance, that would leave us with this distance, which would be 4. Now, if you want to write that as with our segment addition, we could call this x. We know that x plus 17 would be equal to the whole distance of 21, and you would get the same thing, that x would have to be a distance of 4. Now let's apply the algebra. Let's talk about, I kind of did on that last one, let's apply more algebra. If EG is 71, the distance from E all the way to G would be 71. EF here has a distance of 8x minus 17. F to G is a distance of 5x minus 3. Now we're going to be doing lots of algebra in geometry, and this is our start here. How are we going to piece that together? We have a relationship. We know that 8x minus 17 which is the distance from here to here. The segment addition postulate says if I take it and 5x minus 3, if I add those two values together, the distance from here to here plus the distance from here to here, that will give me, or it will equal the entire distance, which we know is equal to 71. Let me put 71 in blue as well, so we can see those three line segments. The small line segments added together is equal to the whole line segment. Okay, this is what we're going to do. We've set up here an equation. We're now going to solve this equation to figure out what x is. And once we know what x is, that opens up a lot of other things that we can do. Okay, combine like terms on the same side. On the left side, I have 8x and 5x. Let's put them together. That's a total of 13x. I have also like terms of negative 17 and negative 3. Let's put them together. That would be a negative 20. Bring down your equal sign and bring down your 71. Basic equations. Okay, now to get x by itself, I've got to get rid of minus 20. I'm going to move it to the other side by adding 20. And now I'm left with 13x on the left side and 91 on the right side. Last step, since these are being multiplied, I'm going to divide by 13. And I'm going to find out that 91 divided by 13 is 7. So my x has a value of 7. Now, what does that tell us? Let's go back and let's just show you. They don't ask to do this, but let's just show you what that actually tells us. Since now x is equal to 7, right here where I have an x, right here where I have an x, they're no longer variables. They're now constants. We know what x is. X is 7. So right here where I have an x, I can now say 8 times 7 minus 17. Over here, 5x minus 3 is now 5 times 7 minus 3. X is no longer x, it is now 7. If you do 56 minus 17, it gives you 39. If you do 35 minus 3, it gives you 32. And look at this. The distance from here to here is no longer 8x minus 17, it's 39. The distance from here to here is no longer 5x minus 3, it is now 32. And if you check, put those two together, you do have a total distance of 71 there. It does check out. Number 4, doing the same thing. The segment addition postulate says this line segment, when added to this line segment, is equal to the whole line segment, which is TV. Or you could say that TU, when added to UV, would equal TV. That's the segment addition postulate. Well, guess what? We know what TU is. TU, which is right here, is 9x plus 2. If you add that to UV, which is 5, it will equal the whole distance, which is 14x minus 8. Combine some like terms. 9x has no like terms over here, but plus 2 and plus 5 are like terms. The right side stays 14x minus 8. Now let's move some x's. If you want to move your 14x's, you can do so by doing minus 14x. If you're going to put your x's on the left side, let's move our 7 to the right side. 9 minus 14 is a negative 5x. Bring down your equal sign. Negative 8, negative 7 is a negative 15. Last step, divide by negative 5, and you get that x is 3. Now, is that what they ask you to find? Do they say find x? No. And this is probably one of the most commonly missed thing in all of geometry is not reading the directions, not looking for what we're supposed to look for. Since we now know that x is 3, right there's your x, this line segment is no longer 9x plus 2, it is 9 times 3 plus 2. And once you work that out, 9 times 3 is 27, 27 plus 2, this line segment is now 29. So the distance from here to here, t to u, is 29. The distance from here to here is 5. If we want to, we can go ahead and find the distance up here, and that way we'll know if we're right. This x is also 3. So we've got to do 14 times 3 minus 8. That's 42 minus 8. And if you do 42 minus 8, you get 34. So this is 9, or 29, excuse me, 29. This is 5. The whole thing, 34, and that does check out. 29 plus 5 gives you 34. Number 5, JK and KL, when you add them together, this line segment plus this line segment, it will equal the whole line segment, which is JL, which they give you up here. This line segment plus this line segment will equal the whole line segment. That is the segment addition postulate. That's what I have here in this equation. Let's combine some like terms. And for some reason, my 5x plus 2 jumped over. My like terms on the left side are 27 and negative 1. 3x has no like terms, so I like to write my x stuff first. 27 and a positive 27 and negative 1 is a positive 26. Bring down your equal sign, and you have 5x plus 2. There are no like terms on the right side. We're going to move our x's to one side. This time, it doesn't matter. I'll move my 3x's by doing minus 3x. If you're going to move your x's to the right, put your numbers on the other side. 26 minus 2 is 24 is equal to 2x. When you divide by 2, you'll get that x is 12. Now that you know that x is 12, this is now 3 times 12 minus 1, which is 35. This is 27. We already knew that. This 5x plus 2 is now 5 times 12 plus 2. 5 times 12 is 60, plus 2 is 62. And you can check. 27, when you add it to 35, does in fact give you 62. So what is JL? JL, let's see, this is JL up here is 62. That's the whole length. Number 6, when you add the length of CD, which is x plus 3, to the length of DE, which is 8x minus 9. Well, let me write that again. When you add those two lengths, it will equal the whole length. And the whole length, which is the distance from C to E, is right here, 7x plus 4. Combine your like terms, that'd be the x and the 8x, which would be a total of 9x. The positive 3 and the negative 9 is a negative 6. Equals, bring down 7x plus 4, no like terms on the right side. Let's move our 7x by subtracting. Let's move our minus 6 by adding. That gives me 2x over here, bring down equals 10. When you divide by 2, you'll get that x is 5. Let's go back and plug it in. This is no longer x plus 3, it is now 5 plus 3. So I'm going to write it above it, 5 plus 3, which is 8. So the distance from C to D is 8. This is no longer 8x minus 9, it is 8 times 5 minus 9. That's 40 minus 9, which is 31. Now look at this. From C to D is the distance of 8. From D to E is a distance of 31. If we did this correct, 8 and 31 should be a distance of 39. Let's check and see. Up here, 7x plus 4 is no longer 7x plus 4. It is now 7 times 5. Plus 4. That would be 35 plus 4, which is a total of 39, which is what we said it should be. So look at the directions. Find the value of x. So which one of these things is our answer? X. X is equal to 5, final answer. Number 7, now we're going to be finding everything. SK is 13x minus 5. That's this distance. KY is 2x plus 9. So when I take 13x minus 5 and 2x plus 9, that's my two smaller lengths. When I add those lengths together, it will equal the total length. It will equal SY, which is 36 minus X. So there's your equation. On the left side, combine your like terms. That's 15X's. A negative 5 and a positive 9 is a positive 4. Bring down your equal sign. On the right side, you have 36 minus X. Let's move our X by doing plus X. Since X's are on the left, let's move our 4 by doing minus 4. 15 plus, that's 1x, that'd be 16x. Bring down the equal. 36 minus 4 is a 32. When you divide by 16, you'll get that x is 2. So my lengths, my distances are now 13 times 2 minus 5. 13 times 2 is 26 minus 5, which is 21. That's the distance from S to K. That's what it says. From K to Y, my distance is 2 times, again, X is 2. So you have 2 times 2 plus 9. That's 4 plus 9, which is 13. So the distance from K to Y is 13. And you can think ahead. If this is 21 and this is 13, we should get a total distance. Have in your head what that is. But 36 minus X is now 2. When you do 36 minus 2, you get 34, which is the value we got with 21 and 13. So that does check out. So our values, it says find X, that was 2. It says find the distance from S to K, that was 21. Find the distance from K to Y, that was 13. And the distance from S to Y was 34. And again, you can check that right here. 21 plus 13 is equal to 34. It does check out. Okay, next up, midpoint. By definition, here's what a midpoint is. The midpoint, and think about the word midpoint. Mid is short for middle. So a midpoint is a middle point. So the midpoint of a segment is a point that divides the segment into two congruent segments. So a midpoint. Now let's go over here and look at our drawing. AC. If we're talking about line segment AC, B is the midpoint. It's the point that's in the middle. So therefore, since B is a midpoint, it makes AB and BC the same length. The distance from A to B is the same as the distance from B to C. That's why this is in the middle. So a midpoint will divide a segment into two congruent segments. Okay, a line, ray, or segment that intersects a segment at its midpoint. So now we're talking about like this line right here. This line goes through this midpoint. Now, what does this line do to this other segment? It cuts it in half, right? This line slices it right through the middle. Another geometric word for that. A line that cuts it through a midpoint is said to bisect. So what does the word bisect mean? It means it cuts it in half. So it's said to bisect the segment, and it is called a, well, that would make sense, a segment bisector. So something that cuts something else in half. Whether this is a line segment, it could be a line, it could be a ray, but if it cuts this segment in half, then it is a segment bisector. Next up, in the diagram at the left, now we're going through all the different pieces, and let's label them here. In the diagram at the left, B, point B, because it is a point. Point B is the midpoint of AC. You put your line segment. It's not a line. AC is a segment. So let me read it again. Point B is the midpoint of AC. So point B is the middle of line segment AC. And line L, here you got your line L. Line L is a segment bisector because it cuts it in half. So line L by definition is a segment bisector of AC. Okay, now let's apply some of these definitions. Again, if something is a midpoint, it's the middle point. It cuts the two sides in half. So if Q on the next problem is a midpoint of PR, that means this is the middle. That means the distance from here to here is the same as the distance from here to here. Well, think about what we just said. In geometry, anytime that you say that two things are the same, then they are equal. That's anytime in math, period. Okay? Or we know that if two shapes are congruent or two line segments are congruent, that means their distances are again equal. So if Q is the midpoint, that means that PQ, which is 7x minus 16, and QR, which is 4x plus 2, have to be the same distance, have to be the same length, so they are equal. You just put the equal sign in between, in the middle of the two. Why? Because that's the middle. We're going to move our 4x by subtracting. Mark out the 4x. Move the minus 16 by adding. Mark out the minus 16. 7 minus 4 gives me a total of 3x. Bring down the equal sign. 2 and 16 is 18. Last step, divide by 3, and you find out that x is 6. Check that. 7x minus 16 is no longer 7x minus 16. It is now 7 times 6 minus 16. That would be 42 minus 16, which is 26. 4 times x plus 2 is no longer 4 times x plus 2. Is now 4 times 6 plus 2. Why? Because x is 6. 4 times 6 is 24 plus 2, which is 26. Now look at these two measurements. PQ is 26. QR is 26. Is that what we needed? Yes, it was, because Q's in the middle. So what is the value? Go back up here and see if we found it. Value of x would be 6. Now, if you think about this, it'd be really hard if you're plugging these values in. It'd be really hard to miss one of these problems because they check themselves as you plug these values in. Number 9, h is the middle. So if h is the middle, then 5x plus 2, that distance, and the distance from 9x minus 10, or excuse me, from h to I, which is 9x minus 10, those two distances have to be the same, which means equal. Move your x's. It doesn't matter which one you move. I like to move it to where my x's are positive. So if you move minus the 5x by doing minus 5x, notice your x's will be positive. You're going to move the 5x, then the minus 10 is going to have to come to this left side. 2 and 10 is 12. Bring down the equal sign. 9 minus 5 is 4x. Last step, to get rid of the 4, you're going to divide, and you'll get that x is 3 because 12 divided by 4 is 3. So now everywhere you have an x, you put 3. This means 5 times 3, which is 15, plus 2, which is 17. This means 9 times 3, because x is 3. 9 times 3 is 27, minus 10 is 17. So since these two distances are the same, that means it checks out. Then that must be the middle. Make sure you find what they ask you for. It says find GH, so therefore right here is going to be your answer, 17. Same thing on number 10. R is in the middle. If R is in the middle, that means that 2x plus 16 and 5x minus 17 would have to be equal. Those two distances are the same. Let's move my 2x by subtracting. If you're putting the x's on the right, put your numbers on the left. Gives you 33 equals 3x. When you divide by 33 by 3, it gives you 11. So since x is 11, this is now 2 times 11. That's 22 plus 16. That would be 38. This would be 5 times 11, which is 55, minus 17, which is 38. So now this one's a little bit trickier, though. Find QS. QS is the distance from here all the way to here. Wait a minute. That's that segment addition postulate again. If this distance is 38 and this distance is 38, then to find the whole distance, you add the two together and it gives you 76. Another one says G is the midpoint. So that means without even doing anything, reading anything else, 4x minus 3 and 7x minus 12 have to be equal. Let me move 4x by subtracting. Let's move minus 12 by adding. 15 is equal to 3x. Divide by 3, it gives you x is 5. So let's go ahead and plug those in. 4 times 5 is 20 plus 3. So the distance from F to G is 23. 7 times 5 is 35 minus 12. You already know what's going to be 23. Now let's read the rest of the question. And FH is 6y minus 2. Wait a minute, I thought FH, it didn't give me anything about FH. However, look, FH, that's this whole length. Now that we've done all this work, guess what? We know how long FH is. And if we know how long FH is, we can figure out what Y is by doing this. The distance from F to H is 23 and 23, which is 46. But I thought FH is 6Y minus 2. Now, that's a variable representation of FH. We actually know how long FH is. So if we know that FH is 6Y minus 2, we also know that FH has a length of 46, then those two things have to be equal because this is FH and this is also FH. FH is 6Y minus 2, FH is also 46, so those two things, since they're both FH, they must be equal. So let's solve it, and we're going to, because it says figure out what Y is, solve it by adding 2, gives you 6Y is 48. The last step, we're going to divide by 6 to get rid of it, and we know that Y would have to be 8.